This is Allison from East Cobb Tutoring Center, and we are going to talk about graphing rational functions using asymptotes and wholes. So let's start with an equation. We're going to start kind of basic and then work our way up. So the first thing we're going to talk about will be vertical asymptotes. So in this problem, to find the vertical asymptote, all we do is take the denominator and set it equal to 0 and solve it. So x equals 4 is the vertical asymptote. One thing to note here is that teachers get very upset when students just write 4 as the answer, because an asymptote is an equation. So we need to make sure that we write it, as x equals as an equation. So here we go, 1, 2, 3, 4. This is my vertical asymptote. We haven't talked about horizontal yet, but it is here at 0. Now, to figure out what the graph looks like, we could just make a t-table and plug in some points. That would be an acceptable way to do it. Let's see, if I plug in x equals 3, I'm going to get -1. So that tells me that the general shape is going to look something like that. Because remember, as it goes out to the left, we are getting closer to the asymptote. And then I could plug in a number on the right side of the asymptote. I'll plug in 5. That gives me +1. So we're up here. So in summary, to find a vertical asymptote, just set the denominator equal to 0. Now let's talk about finding a hole in the graph. Sometimes we're given equations that need to be factored before we can do much with them. So let's take a look at one of those. All right, so in this problem, sorry, I'm having some trouble with my pen, x squared minus 4. I'm going to begin by factoring the numerator and the denominator. So x minus 2 and x plus 2, that's the difference of 2 squares. So what's going to happen here is that the x minus 2 term is going to cancel. I'll show you what I mean, just like that. Right? Oops, wrong one. Oh no. Undo that. This one. So it leaves me with just y equals 1 over x plus 2. So what's happening here is that the guy that canceled out that at x equals 2, that's the hole. A hole happens when something cancels away. And then the remaining term down here, that x plus 2, that's what we're going to solve to get the vertical asymptote. Okay, and that could also be found from our simplified version. So in summary, a hole is what happens when something cancels out. Now, a hole is actually a part on the graph, and it is an ordered pair. So to find the y value for the hole, what you do is you take the x value and you plug it into the simplified form. So if I plug 2 in 1 over x plus 2, the y value I'm going to get is 1/4. So the hole occurs at 2, 1/4. So follow your teacher's lead on that one if your teacher wants you to write it as x equals for your hole or as an ordered pair like that. All right, so next we're going to talk about the rules for horizontal asymptotes. So imagine that we have a rational function that's in this form, and the numerator and denominator are both polynomials. So we're going to be looking at the degree of the numerator and the denominator. Remember, the degree is the highest exponent of your polynomial. So 3 things can happen. If the degree of p is less than q, so say the numerator is x and the denominator is like an x squared, then the horizontal asymptote occurs at y equals 0 every time. Let's see. Y equals, there we go, 0. All right, the next situation that could happen would be if the degree of p is equal to the degree of q. When the degrees are equal, then our horizontal asymptote occurs at the fraction of their leading coefficients. I'll show you what I mean about that. Hang on just a sec. Okay, so for example, if I had x squared minus 4 over 3x squared plus 9, my horizontal asymptote would occur at 1/3. The numerator and denominator have the same degree, they're both 2, so I just make a fraction of the leading coefficients, and that would be the horizontal asymptote. All right, there's one more case that we have to think about, and that is what happens when the degree of P is greater than the degree of Q. And in that case, we have no horizontal asymptote, and instead we get a slant asymptote. So we are going to talk about a slant asymptote in another video. So that's it for now.